Okay, we're going to cover two shapes today. And that's how a lot of this is going to go. We're going to talk about shapes. Today, excitingly enough, parallelograms and rectangles. So you probably know what these things are. If I hiked on it enough, I could probably get you to give me a definition of parallelograms and a rectangle, probably more so rectangles than parallelograms. But there's a lot of subtlety that goes along with these figures that we're going to have to talk about. Okay? So these are subcategories of quadrilaterals. So you remember the other day when we were doing all those different colored polygons. I don't know if it happened in here, but I know it definitely happened in another class. I asked somebody what that four-sided thing was, and they told me it was a trapezoid. When in fact, that's a type of quadrilateral. So from this point on, we're talking about different types of quadrilaterals. The first one, and the most general one, is a parallelogram. Okay? So there's a parallelogram. Notice, it's a little hard to see, but you'll notice the arrowheads on there. Why are there arrowheads on that yellow parallelogram? What do they mean? Chris?
It shows what sides are equivalent.
Not equivalent. Nope. Go.
Parallel.
They're parallel, right. It's a parallelogram. Therefore, it has some parallel sides. Emma, how would you define that yellow thing? A parallelogram is? Great start. Let's give a general category to quadrilateral. That?
That has two sets of parallel lines.
Perfect.
Or segments.
Everybody at home hear that? No. Okay, so what she said is it's a quadrilateral with two pairs of parallel sides because it's a parallelogram. Okay? Almost identical to what you said. Nice job, Emma. Okay, so that's the definition. Now I'm going to bombard you with all kinds of information about that parallelogram. Beyond the fact that it has opposite sides parallel, there's a ton of information that's true about it. However, before we do that, let me give you a couple other tidbits of information. First of all, there is a symbol for parallelogram, so you don't have to write it out over and over again. The symbol for parallelogram, strangely enough, is a parallelogram. Now we're going to run into some scenarios where you have to name a parallelogram. And that'll happen two different ways. I'll give you the listing for the parallelogram, or I'll give you the picture and you need to list it. So for instance, let's suppose this parallelogram was MNOP. In a triangle, the name didn't matter. Triangle ABC is the same as BCA, is the same thing as CBA, is the same thing as all the other 6 possibilities. You have to be very careful in a parallelogram. Its naming starts by picking one vertex. John, what vertex do you want?
P.
P. And going either clockwise or counterclockwise from P. Clockwise or counterclockwise?
Clockwise.
Clockwise. So this parallelogram would be P, M, N, O. Could he have gone the other way? Yes, that's also parallelogram P, O, N, M. He could have picked a different starting point. Could have done N and done NOPM or NMPO. And this seems silly, like why do we care? The reason we care is because what doesn't work is this. Does everybody see why this is bad? Yes?
It's not in order.
Good. Perfect. It's not in order. If I trace this PNMO, I get PNMO, and that's not a polygon. That's a mess. So you got to go in order around the shape. And the same is true if I give you the name and ask you to draw it. If I give you parallelogram A, B, C, D, you just got to be sure that you go in order, either clockwise or counterclockwise. So the naming schematic for a quadrilateral is fairly tricky. Okay, so let's move on. What else do we know about a parallelogram? Well, we know that the opposite sides are congruent. We already know, based on what Emma told us, that the opposite sides are parallel. Not only are they parallel, they're also congruent. Same length, in other words. And we also know that the opposite angles are congruent. Now, I'm going to go through these properties quickly. If I go too fast, just say something I can back up or slow down. And so there's a picture illustrating those two properties. Opposite sides are congruent. Hi, Mr. Minter.
Morning.
And opposite angles are congruent. Notice the different tick marks. One angle mark is congruent to one angle mark. Two angle marks equal to two angle marks. Okay, let's get into it here. Let's call this X and this vertex Y. Here we go. What's the relationship between angle X and angle Y? All right, you're on a run. Go, Daniel.
You add them up together, they're equal to 180.
Perfect. What's the fancy term for that? What's the meal you eat after lunch?
Dinner.
You're right, it is dinner, but they're not called dinner, supplementary angles.
Supplementary.
Good, they're supplementary. Okay. So, Daniel, let's stay with you. Suppose I call this Z. What's the relationship between angle X and angle Z?
Supplementary.
And Z and W?
Also supplementary.
WY.
Supplementary.
Excellent pattern recognition skills. Good. How do I phrase that?
Angle Z.
So, okay, so hold on, let me interrupt and see if I can help you. We know that angle X and angle W are opposite angles. They're across from each other. We know that angle Y and angle Z are opposite from each other. How would you express the two angles X and Y? What kind of angles are those? Other than supplementary, because we did that already. But I give somebody this picture and I want to try and tell them what you just told me. How would I describe it, angles X and Y? Anybody else?
Same side interior angles?
Ooh, very nice. That's why they're supplementary. Good. Consecutive angles, adjacent angles, same side interior angles, all of those say the same thing. The angles next to each other are going to add up to 180 degrees. Good. So this is where you don't have to blindly just write down what I'm telling you. If you don't like the word consecutive, if you don't know what the word consecutive means, I've given you at least two different ways to say the same thing. Adjacent angles. And I didn't notice who said that. Emily, was that you before?
Yeah.
Thank you. Emily also said, well, the same side interior angles are supplementary. Mr. Chong, how are you, sir? Diagonals bisect each other. What is this voodoo? Well, if we go back to this picture, all the way back to this guy, okay, we talked about how naming is important because you don't want to go out of order, because when you go out of order, you get these segments here, this one and this one. And I think we've talked about this, but in case we haven't, those are called diagonals. Diagonals connect non-adjacent vertices. And in a parallelogram, those diagonals bisect each other. Bobby, what does it mean to bisect each other?
What does it mean to bisect?
Yeah.
So I like divide them into two equal parts.
Love it. Okay. Cut them each into two equal parts. Now notice the markings here. They're not all congruent. We're taking one green segment, chopping it in half. We're taking the other green segment, chopping it in half. And where they do that, this point is what's creating that. Bonus question, Bobby. What's special about that red point I just drew in that picture?
is the center.
Keep going. What's the other name for a center, for the center of a segment?
Circumcenter?
No. Now you're getting too fancy in your pansies. Want some help?
Yeah.
Anybody else? What's special about? Oh, sure. Why not, Daniel?
And the midpoint between
Beautiful.
those lines.
Yep. That's the midpoint. If they're going to bisect each other, then they're going to have to pass through each of their midpoints. So they share a common midpoint. Thank you, Bobby. Okay, here we go. Please figure out how big angle D is. Your first reaction is, I can't do that. You didn't tell me about angle D. Well, that's part of the challenge. And notice, it is a parallelogram. All right, go. Don't be bashful about busting out those calculators. You might need them. Somebody just left. They had enough. All right, Neil, let's go to you. Before we dive into the pool, let's just dip our toe in it. What'd you get for X?
I got 27 for X.
Okay, hold on 1 second. Whoop. Can somebody confirm? Oh, good. We got a number of confirmation there. How did you get that X, Nia?
I did 4x minus 9 is equal to 3x plus 18, and then I solved for x.
Love it. We'll assume that everybody can do that and get X equals 27. Excellent. Okay, that's the first part. Now, how do you deal with this puppy? How do you deal with angle D? Wait. Still you, Nia.
I think you plug the x back into like either 4x minus 9 or 3x plus 18.
Okay.
And then
I love that. When you do it, what do you get?
From 180.
Okay, so what's 4 times 27 minus 9? Anybody?
99.
99. And then I do what with that, Nia?
You do 180 minus 99.
Perfect. Which I believe is 81, yes? Good. Okay, so let's talk about why she did that. Well, angle A and angle C are opposite angles in a parallelogram. We just talked about the fact that they are congruent. She set them equal, solve for x. Plug it back in. Now we know the measure of angle A and angle C. So, at that point, you have a couple options. You might recognize that A and D are supplementary because they're adjacent angles in a parallelogram. If you don't, you also know that all 4 of the angles add up to 360, and angle D and angle B are congruent. So you could do 99, or 360 minus 99 divided by 2, and you'll get the same answer of 81. Well done, thank you. Questions? Beautiful. Not working. There we go. Okay, now let's make things interesting. Let's take a parallelogram, or something we think is a parallelogram, and and put it on a coordinate plane and do some calculations. It's been a while since we've done this, so this will be a good refresher for some of you. By the way, saying that I graphed it is not good enough. We're going to have to do some work. All right, so I'm pretty good at plotting. Let's put R there. S is at 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. S. And then T is at 8, 8. 3, 4, 5, 6, 7, 8. 1, 2, 3, 6, 7, 8. Let's go T there. And then 1, 2, 3, 4, 5, 6. 1, 2, 3. V. And I believe it said, yes, RSTV. RSTV. Whoa. All right, I missed a little bit. We'll go with it. I think that might be a parallelogram. Now, there are a lot of different ways to check it. And in fact, any one of the things that we talked about already would allow you to show that that's a parallelogram. So let's start with the simplest thing. I believe it was Emma that gave us a definition. Is that right, Emma? So we could talk about parallel sides. How do I know if RS and VT are parallel? Sure, why not, Daniel?
You can find the equation for the line they have to match, or the slope has to match.
Oh, there we go. Yeah, big difference. Slope matches. Okay. So things are parallel on a coordinate plane if they have the same slope. Find the slope of RS. Find the slope of VT. See if they're the same value. Find the slope of ST. Find the slope of RV. If those match, it's parallel. Good, that's one method. Now, what other properties did we talk about? We said that the opposite sides are congruent. How do I know, or what do I do to see if, oh, I don't know, that ST is congruent to RV? How do I check that? Zoomers, feel free to jump in. Nobody? How would you check distance on a coordinate plane? Lorenzo, what would you do? Mia, do you know?
Plug it into the distance formula.
How would you check distance? You'd use the distance formula. On your calculator, save yourself a lot of hassles. So there's another way to do it. Check to see if the opposite sides are congruent. Now, one thing that we talked about that doesn't work very well is checking opposite angles. Right now, we don't have a lot of, we can do it, it's just too much work to show that angle S is equal to angle V and angle R is equal to angle T. There is a third way, though. One of the things we talked about is the diagonals. And we said that if this is a parallelogram, then the diagonals bisect each other, which means that that blue dot is the midpoint of both diagonals. So you could find the midpoint of SV, find the midpoint of RT, and show that it's the same point. That's three different options to do the same thing. A lot of that is what works best for you. Some of you are horrible at calculating slopes. That's okay. Use your distance formula, because you can do that. Some of you are horrible at distance formula because you don't have it on your calculator yet. That's okay. Use the diagonals. You can find a midpoint. Of those three things, one of them you should be able to work. Are you going to do a distance? Are you going to do a slope? Or are you going to do a midpoint? You don't have to do all of them. You just got to do one. Okay? So, Julia, P.
Yep.
Which one you want? Distance, slope, or midpoint?
I guess the distance formula maybe.
I like the distance too, so we'll use that one. Just because I know you bums have it. John, could you do the length of RS for me? And Chris, you do the length of VT. And then Megan, do, which one are we on? We're on ST. And then Mia, do RV, please. And then when you get your values, just shout it out. You got it, John?
5.39 or the square root of 29.
All right, we'll go 5.39. Chris?
I don't have the distance.
Oh, boy. Do the other one for me, John.
5.4.
And then RV?
5.4.
Ooh. Should be 5.39, I think, but I'll wait. Yeah, okay. All right, so not only did we learn, well, we learned something interesting. All four sides are equal. But it's still a parallelogram because we have to have the opposite sides parallel. Perfect. I personally like working with the distance formula because I'm going to use my calculator. But again, if that doesn't work for you or you don't have the distance formula on your calculator, then that calculation can get to be a pain in the butt, and I would skip it and probably do a midpoint or a slope. Okay, moving on. We did the diagonals already. Oh, going back to this picture. Where is it? This guy. Notice that when we draw the diagonal in, we have a whole bunch of triangles that are equal to each other. So, for instance, this triangle is equal to this triangle. This triangle is equal to this triangle. But also, we have the halves. Whoops. I don't know what just happened there. Let's try that again. This half is equal to that half. Well, that's becoming very, it looks like the Jamaican flag. And then this half is equal to that half. Bunch of congruent triangles in there. Okay, so then, boom. We're running short on time, so we're going to skip this real quick. Or actually, we're not going to skip it. I'm going to take you through it very quickly. I know that the opposite sides are parallel. So if I include that in the picture, I know that that's parallel to this, and this is parallel to this. Using all the parallelogram properties we already talked about, I know that this is going to be equal to that because the diagonals bisect each other. Set 8s equal to 7s plus 3, solve. Bingo. I know that this is equal to this because opposite sides in a parallelogram are congruent to each other. I know that if this angle is 40, then this angle is going to be 40. How do I know that? Those are alternate interior angles. So 2t equals 40, and that gives us t. So there's all three of them, different ways to find it. Notice we don't need that chunk of information. However, I do know that that's also going to be 18, just for discussion purposes. Okay? So being able to apply all of those properties of a parallelogram become important. Okay? And then the same thing here. We're going to skip this one. We'll move on. Okay, good. Questions on parallelograms? One of the things that we're going to spend a lot of time with quadrilaterals, discussing about quadrilaterals, is the dog/golden retriever approach. Do you remember what I mean by that? Anybody? Go, Daniel.
All golden retrievers are dogs, and all dogs are golden retrievers.
Perfect. The same is true with quadrilaterals. So as we transition into rectangles, the question I would have for you is a rectangle a parallelogram? And or is a parallelogram a rectangle? Okay, so we know by definition that a rectangle is going to be a parallelogram with four right angles. Now, how do we know that? Because a rectangle satisfies all the conditions that we needed for a parallelogram. So in this case, is the rectangle the golden retriever or the dog?
Golden retriever.
Right. Because all rectangles are parallelograms, but not all parallelograms are rectangles. So instead of going back through the whole process that we just went through with parallelograms, we're just going to say, okay, hold on. What's true about a rectangle that's not already true about a parallelogram? Because we should have the parallelogram thing under control already. Just like when you're talking about a golden retriever, we know a golden retriever is a dog. It has 4 legs, it has a nose, it has a tail, it barks, that kind of stuff. But what makes a golden retriever a golden retriever? Comment. Say it loud so they can hear you.
The rectangle has to have 90-degree angles.
Good. 4 right angles. Okay. Anything else? Chris?
They're all, yeah.
Did I lose you there?
Well, I was gonna say all sides are 90 degrees, so that's sort of the whole idea for it.
Okay, so this second line, opposite sides are parallel and congruent. We know that because it's a parallelogram. The first one is unique for a rectangle. The second one is a repeat. The third one is new. Okay. Oh no, sorry, opposite angles are congruent. That's old. That's old. That's old. So here's a rectangle. One of the biggest differences between the parallelogram and the rectangle is twofold. Number one is the 90-degree angles, but number two is the difference in the diagonals. Notice that in this picture, the diagonals AC and BC are congruent. They still bisect each other. Okay? This is still the midpoint of both of them, but we also know that this is equal to that. That's not true in a parallelogram. So as far as your notes go, what I would say is, since we know it's a parallelogram, don't repeat yourself and copy all this gunk down. Because the only thing that's relevant here is this first one. Everything else is a repeat, which we already have under control. Then this is new, that the diagonals are congruent. In a parallelogram, they bisect each other. In a rectangle, they are congruent to each other. Am I going too fast? Are we good? We're good? Okay. Well, this seems kind of a silly question, but maybe it's not. If SO is 200, how long is NE? So instead of answering that question, let's answer the first question. How long is NW? 200. So therefore, how long would NE be? 100. Good, because they bisect each other. Excellent. Okay. Really simple. FD is 3x minus 7. EG is x plus 5. And we're not going to bother. It's ridiculously easy. Why? Because we know that those are congruent. You should all be able to solve 3x minus 7 equals x plus 5. This one, however, might require a little bit more work. EFD and DFG. So for those of you that are visual learners, EFD is this angle, and in red, this one, and then in blue, DFG is that angle. What's the relationship between the blue angle and the red angle? Go. Complementary, which means, for the layman,
If you add them all together, they equal 90.
beautiful. So let's forget about that for a second, and let's work our way around the rectangle a little bit more. Okay, instead of solving this problem, let's talk more about these angles. First of all, what kind of triangle, Ainsley? What kind of triangle is AEF?
Equilateral? No.
There's a reason why I called on you.
Is it not isosceles?
It is isosceles. How do we know that? Well, the diagonals are congruent, they bisect, so now all four of these are equal.
Oh, I was looking at the wrong triangle.
Oh, okay, my bad,
That's
sorry.
my fault.
I'll take the blame on that one, even though I had nothing to do with it. This angle is the same as that angle, because it's an isosceles triangle, and the base angles are equal. This angle is also equal. Alternate interior angle. This angle is equal. Now I got all of a sudden four angles that are all the same. And I think you can see where this is going here. Equal, equal, equal. So we got a whole bunch of congruent angles in there. Four isosceles triangles, two pairs of four, no, that doesn't make any sense. Two types of angles, four examples of each in that picture. And then just to make things a little bit more confusing, this angle is equal to that angle, and this angle is equal to that angle. We're done with day 2. There's a fast fact about pigeons, in case you care. Okay. So the homework tonight is parallelograms and rectangles. Don't get bogged down with rectangles. Just, again, it is a parallelogram, so all the things we talked about with parallelograms applies to rectangles. The question you should be considering is, what's the difference, or what does a rectangle have that a parallelogram doesn't have? Okay? Questions on